How excess nitrogen due to agriculture affects the environment. The first step in understanding how excess nitrogen can affect our planet is understanding the nitrogen cycle. The first step of the nitrogen cycle is nitrogen fixation, and it's the process of taking that biologically unavailable form of nitrogen, the N2 molecule, and turning it into a more usable form like NH3. So this process is done naturally in the air by lightning and also reacting with water in the air. So lightning and reacting with water in the air. And also is done by these symbiotic prokaryotes here and free-living prokaryotes here, which do the same process of converting N2 into NH3. Now the second step of the nitrogen cycle is nitrification, and this is the process of converting the NH3 that was just converted into NO2-, and this again is done in terrestrial locations, most commonly by free-living prokaryotes here, the green squares, and again they take the NH3 and they turn it into NO2-. Now as described here, there is a second step to nitrification, and this is the process of converting NO2- into NO3-. And this is done here by the second nitrification bacteria, and they're a completely different group, as you can see, than the first nitrification bacteria. Now the last step of the nitrogen cycle is denitrification, and it's the process of converting NH3 and NO2 and NO3- back into unavailable N2. So I'm just going to draw that out here for you. It's done in the soil like the last two processes by these free-living denitrifying prokaryotes, and it's NH3. I'm just going to draw one of them out. Back to N2. There we go. Now, once this is converted back into its biologically unavailable form, it's going to diffuse back into the atmosphere. I'm just going to draw in yellow. The cycle continues with all these conversions of the nitrogen. Now that you know about the natural processes of the nitrogen cycle, we're going to talk about the human impact. So humans have drastically changed the amount of global nitrogen in the past 100 years by the burning of fossil fuels, the Haber-Bosch process, and increasing the production of legumes. So here's a few facts for you, and the main issue we're going to focus on today is that the increased nitrogen increases aquatic deposits of nitrogen. There's a few numbers there. So this is just a helpful visualization of what happens with human increases in nitrogen. So the Haber-Bosch process, fossil fuel production and burning, and legume and pea cultivation, which is increased, causes huge increases in global nitrogen here. So you can see the Haber-Bosch process in blue, fossil fuels in yellow, and legume cultivation in green here. Now in this darker green and red, you can see the natural processes, which oddly enough have decreased in the past 100 years and are projected to decrease even more. So I'm just going to show you what this looks like real quick. So here we have our factory where up here in yellow it's burning fossil fuels, and this releases various N compounds into the atmosphere, and we'll talk about the effects of that later. And then here in blue we have the Haber-Bosch process, which through the burning of fossil fuels actually takes this N2 molecule and converts it into another biologically available N molecule, which we'll just use NH3 for an example today. So then this NH3 molecule is put into fertilizer for crops and given to farmers, and then they put it onto their crops to increase crop yield. So here I've drawn two different kinds of plants. So you can see here these ones are shorter and they're less dense, whereas here they're more dense and they're taller. So this section has been sprayed with nitrogen fertilizer, and it's increased the crop yield for the farmers, producing more food. But there are a few issues with this increased production because of the nitrogen. So sometimes this nitrogen from the nitrogen fertilizer stays in the soil. Sometimes it actually runs off, which we'll talk about later. And I'm going to talk about now is when it diffuses into underground water supplies. So here you can just see it in the water. And this becomes an issue when it moves into lakes, into the ocean, and into the atmosphere again.